Hello everyone. In the last video we learned about list. Today we are going to learn about tuples, another collection data type in Python. If lists are like a flexible notebook where you can erase and rewrite, tuples are like a printed research note. You can read and use them, but you cannot change their contents once they are created. Alright, let's understand what a tuple is. A tuple is an ordered collection of items. That means the items inside it stay in the same order as when you created them. It looks very similar to a list, but the big difference is that tuples are immutable, which simply means once you create a tuple, you can't change it. You can't add, remove, or update the items inside. We create tuples using parentheses. You put your items inside the round brackets separated by commas. And just like list, the items inside a tuple can be of any data type. They can be strings, numbers, or even a mix of different things. For example, look at these cases on the slides. Parenthesis ATG, CGT, TTA. That's a tuple of codons. Parenthesis BRCA1, TP53, EGFR. That's a tuple of gene names. Parenthesis 250, 300, 500, that's a tuple of numbers, which could represent read counts in bioinformatics. So in short, a tuple is a fixed list, ordered, created with parentheses, and it can store any type of data. Now let's see why tuples are useful in bioinformatics. First, tuples are great for storing data that shouldn't change. For example, reference codons or fixed sample IDs. Once you define them, you don't want anyone accidentally modifying them. Tuples protect the data because they are immutable. Second, tuple can be used as keys in dictionaries, while list cannot. Imagine you want to map a chromosome and a position to a mutation. You can use a tuple like chromosome 1, 12345 as the key in a dictionary. This would be impossible with a list. We will see this in detail while explaining dictionary data type. Third, tuples are slightly faster and more memory efficient than list when you iterate over them or look up data. So if you are dealing with large data sets, using tuple can save some performance. Finally, tuples are ideal for fixed length records. For instance, if you want to store a chromosome and a position together as a pair, or return multiple values from a function like gene name and expression level, tuples are perfect because the structure is fixed and clear. In short, whenever you have data that is fixed, needs to be accessed efficiently, or used as dictionary keys, tuples are the way to go. Now let's learn about indexing and slicing in tuples. First, remember that tuples are ordered collections, which means every element has a specific position. Python starts counting positions from 0. This is called positive indexing. In our example, we have a tuple called DNA underscore tuple with 4 items ATG, AAA, CGC, and TAG. If we count from the start, ATG is at position 0, AAA is at 1, CGC is at 2, and TAG is at 3. So when we write DNA underscore tuple 0, Python gives us the first element, which is ATG. Similarly, DNA tuple 1:3 is a slice, meaning we take elements from index 1 up to but not including index 3. That gives us a new tuple with AAA and CGC. Notice the original tuple doesn't change. Slicing always creates a new tuple. We can also use negative indexing, which starts counting from the end. -1 is the last element, -2 is the second last, and so on. So DNA underscore tuple -1 gives TAG, and DNA underscore tuple -4 gives the first element ATG. Finally, we can use slicing with a step. For example, DNA underscore tuple ::-1 gives the tuple in reverse order. TAG, CGC, AAA, and ATG. The double colon means we take all elements, and the -1 tells Python to go backwards. In short, indexing lets us access individual elements and negative indexing counts from the end, and slicing let us extract multiple elements or even reverse the tuple, all without changing the original tuple. Now let's talk about immutability and what operations we can do with tuples. First, tuples are immutable, which means once you create a tuple, you cannot change its elements. For example, if you have DNA underscore tuple equals to ATG, CGT, TTA, and you try to do DNA underscore tuple 0 equals to AAA, Python will give an error. This is different from list where you can freely change elements. Even though we can't change elements directly, we can still do several useful operations with tuples. If you ever need to change elements, you can convert the tuple to a list, modify it, and then convert it back to a tuple. Finally, a small but important detail. If you want a single element tuple, you must include a trailing comma. So immutability gives you safety for fixed data, but you still have flexible ways to combine, repeat, and use tuples effectively. Next, let's talk about tuple unpacking and some practical ways to use tuples in bioinformatics. Tuple unpacking allows us to assign multiple variables at once from a tuple. For example, if we have chromosome position equals to chromosome 1, 1, 2, 3, 4, 5, Python automatically assigns chromosome 1 to the variable chrom and 1, 2, 3, 4, 5 to the variable pos. Tuples are also very useful for function return values. Often a function needs to return more than one value. You can write return a, b or simply return a, b without the parenthesis, and the function will return a tuple containing both values. This makes it easy to capture multiple pieces of information in a single assignment. Another practical use is dictionary keys. Since tuples are immutable, they can be used as keys in dictionaries, whereas list cannot. Now let's compare list and tuples to understand when to use each one. First, the syntax. Lists are written inside square brackets, whereas tuples are written inside parentheses. This is the first thing you notice when reading code. Next, mutability. Lists are mutable, which means you can change, add, or remove elements after the list is created. Tuples, on the other hand, are immutable. Once you create a tuple, you cannot modify its contents. Then, use as dictionary keys. List cannot be used as dictionary keys because they are mutable, but tuples can be used because they are immutable. This makes tuples perfect for situations where you want to map fixed pairs of data, like chromosome and position to values. For typical use, lists are great for collections of data that you expect to change, like a list of sequences you are modifying. Tuples are ideal for fixed records or keys that should not change, like a reference codon list or a coordinate pair. Finally, speed. Tuples are slightly faster than lists for iteration and lookup because Python optimizes immutable objects. This may not matter for small datasets, but for large bioinformatics datasets, tuples can give you a small performance benefit. In short, use list when you need flexibility and mutability, and tuples when you want fixed, reliable, and slightly faster structures. Now we will switch to Jupyter Notebook to see all the concepts in action. Let's start by creating some tuples in Python. First, we create a tuple to store some DNA codons. A tuple is just a collection of items that we don't plan to change. Here we have three codons ATG, CGT, and TTA. Printing it shows all three together in the tuple. Next, we create a tuple for gene names. This one contains BRCA1, TP53, and EGFR. Printing it displays these gene names grouped together, just like the codons. Then we make a tuple for read counts with the numbers 250, 300, and 500. Again, printing it shows all the values together in a tuple. Finally, we check the type of our codons variable. This confirms that Python recognizes it as a tuple. Knowing the type is important because tuples behave differently from lists. Mainly, tuples are immutable, which means we cannot change their contents. So in these few lines, we have created tuples with different kinds of data, strings for codons and gene names, numbers for read counts, and we also verified that Python correctly identifies them as tuple. Now that we know what tuples are, it's important to understand how to access the elements inside a tuple. This is where indexing and slicing come in. Tuples are ordered collections, so each element has a position and we can use that position to get the data we want. First, we create a tuple called DNA underscore tuple that contains 4 DNA codons ATG, AAA, CGC, and TAG. Printing it shows all the codons together. Next, we demonstrate positive indexing. Since tuples are ordered, the first element is at position 0. So DNA tuple 0 gives us the first codon ATG, and DNA tuple 1 gives the second codon AAA. This is useful when we know the exact position of the item we need. We also show negative indexing, which lets us count from the end of the tuple. DNA tuple minus 1 gives the last codon TAG, and DNA tuple minus 2 gives the second last codon CGC. Negative indexing is handy when you want to access elements from the end without counting the total length. Now let's explore slicing. Slicing allows us to extract multiple elements at once. For example, DNA tuple 0:2 gives the first two codons ATG and AAA. DNA tuple 1: starts from the second codon and goes to the end, giving AAA, CGC, TAG. We can even take every second codon using a step. DNA tuple 0:4:2 gives ATG and CGC. Finally, we can reverse the tuple using slicing with a negative step. DNA underscore tuple ::, -1. This gives TAG, CGC, AAA, ATG, the same codons but in reverse order. So this code shows how we can read any element from a tuple, extract a portion of it, or even reverse it, all while keeping the original tuple safe and unchanged. Understanding indexing and slicing is crucial because it's one of the most common ways to work with tuples in Python. Now that we know what tuples are and how to access their elements, it's important to understand immutability and some common operations we can perform on tuples. This is useful because tuples behave differently from lists, and knowing what we can and cannot do will help avoid errors in our code. First, we create a tuple called DNA underscore tuple with three codons ATG, CGT, and TTA and print it. This shows the original tuple and confirms what's inside. Next, we see that tuples are immutable, which means we cannot change element. If we try to assign a new value to the first element, Python would raise a type error. That line is commented out, so the code still runs. Then we demonstrate concatenation, which is combining two tuples. We create another tuple called extra underscore codons with GGC and TAA and add it to our original tuple using the plus operator. Printing combined underscore tuple shows all 5 codons together. After that, we show repetition using the star operator. We repeat DNA underscore tuple twice. Printing repeated tuple shows the codon repeated back to back. We also check membership using the in operator. We ask Python if CGT is in DNA underscore tuple, which returns true. And if GGA is in it, which returns false. This helps us quickly see if a value exists in a tuple. Next, we use the len function to find the length of the tuple, which tells us how many elements it contains. Since tuples are immutable, sometimes we need to modify their contents. To do that, we convert the tuple into a list with list DNA underscore tuple, change the first element to AAA, and convert it back to a tuple. Printing DNA underscore tuple underscore modified shows the updated tuple. Finally, we cover single element tuples. If you write ATG, Python thinks it's just a string, not a tuple. To make a tuple with only one element, you need a comma. Printing the types shows that the first is a string and the second is a tuple. This code teaches us the key aspects of tuples. They cannot be changed directly, but we can concatenate, repeat, check membership, iterate, and even convert them to lists to make changes when needed. It also clarifies how to create a single element tuple correctly. Now we are going to learn about tuple unpacking, which is a neat way to assign values from tuple into separate variables. This is really useful when you have related data grouped together like chromosome coordinates in bioinformatics. First, let's create a tuple called chord. This tuple will hold two pieces of information, a chromosome and a position. So I'll write chord equals to and open parenthesis, then chromosome 1 for the chromosome and a comma and 1, 2, 3, 4, 5 for the position and close the parenthesis. Next, instead of accessing each element with indexing, we can unpack this tuple directly into two variables. I'll write chromosome comma position equals to chord. Now the first value in the tuple chromosome 1 goes into the variable chromosome and the second value 1, 2, 3, 4, 5 goes into the variable position. To check that everything worked, let's print the variables. I'll write print chromosome and then print position Running this shows the chromosome as chromosome 1 and position as 1, 2, 3, 4, 5. So with tuple unpacking, we can take a group of related values and assign them to separate variables in one simple line. It keeps the code clean and easy to read, especially when working with pairs like coordinates. Now we want to understand the main differences between list and tuples. So let's see some examples in Python. First, I'll create a list called my underscore list and put the number 1, 2, and 3 in it. Lists are written with square brackets. Then I'll create a tuple called my underscore tuple with same numbers using parentheses. Printing both shows how they look. The list shows 1, 2, 3 in square brackets and the tuple shows 1, 2, 3 within parentheses. Next, let's look at mutability. Lists are mutable, which means we can change their contents. I'll print a message saying modifying the list is allowed. Now I'll change the first element of my underscore list from 1 to 10. Printing it shows the updated list 10, 2, 3. Tuples on the other hand are immutable. This means we cannot change any of their elements after they are created. I'll print a message saying trying to modify the tuple will cause an error. Then I'll attempt to change the first element of my underscore tuple to 10 inside a try except block. Python raises a type error which we catch and print as an error message. So from this example we see clearly that list can be modified while tuples cannot. This is one of the key differences between them and it explains why tuples are used when we want to store fixed data that shouldn't change. To recap, tuples are like sealed containers, excellent for storing values that should not change. They behave like lists for reading, slicing, and iterating, but protect you from accidental modification and work as dictionary keys. Thanks for watching. If this helped, please like, comment your questions, and subscribe. In the next video, we'll look at another Python data type, that is sets.